Welcome to the week of April 19th geometry recording. I do have a warm-up question that I would like you to complete in your math notebooks that will help you think back to what you've been doing in Unit 8, all about circles, and it's going to help prepare you for this week's assignments. So go ahead and open your math notebook up. And in your math notebook, I would like you to first find the angle measurement of arc UV, and then also find the arc length. So you're going to find the angle measure and the arc length, or the arc measure. I'm sorry, it should say the arc measure, not the angle measure. You need to find the arc measure and the arc length of UV. So go ahead and do that in your math notebook. Remember, you can go ahead and click pause now so that you can do your work on your own, and then you can check your work with mine. Remember, you should be taking notes as you watch this recording. All right, so the arc measure of UV. Let's go ahead and start with the arc measure. The arc measure, remember, is the degree measure of the arc, and it's equal to the measurement of the central angle. So the arc measure is equal to the central angle. So the arc measure of UV, we can write the measure of arc UV, is going to equal the same thing as the central angle, which is 100 degrees. Now to do part B, we need to do a little bit more work. Remember, the arc length is going to be a portion of the circumference. So the arc measure is the arc length is a portion of the circumference. And to find arc length, we've got a little formula. We are going to take the arc measure and divide it by 360 degrees and then multiply that by the circumference of the circle. And remember, to find the circumference of a circle, it's 2 pi r. So that's the formula we're going to use. Remember, m equals the central angle. That's what m represents. So here our central angle is 100 degrees. We're going to divide that by 360. Then we're going to take that product and multiply it by 2 times pi times our radius, and the radius was 150 degrees. All right, let's go ahead and answer that. We'll leave our answer in terms of pi, so we'll go ahead and just leave pi in our answer. So I'm going to take 100, divide it by 360, and then I'm going to take that answer and multiply it times 2 times 150, or 300. And when I do that, so 100 divided by 360, multiply that times 300, because I know 2 times 150 is 300, and I got 83.3 pi. I'm just going to round to 1 decimal place. And we would want to do units of measurement if we did have any. All right, so that's our answer there. Good review of last week. And let's continue on. This week we're going to do 2 sessions, Unit 8 Session 4 and Unit 8 Session 5. Unit 8 Session 4 is all about inscribed angles, and Unit 8 Session 5 is angle relationships between circles. So let's get going there. Inscribed angles. So an inscribed angle is just any angle whose vertex is within your circle. So an inscribed angle is just an angle that not the vertex is on, the angle is within, the circle. So the angle is within the circle. And we have different ways of measuring inscribed angles based on what the inscribed angle looks like. And here is that formula. The measure of an inscribed angle is half the measure of the intercepted arc. So that's why we reviewed how to find the measure of an arc, because you're going to use the measurement of an arc to help you find the measure of an inscribed angle. So if we were trying to find, here's that formula right here, the measurement of an angle is equal, of an inscribed angle is equal to 1/2 the measure of the 1/2 of the arc measure. Kind of just say that in lamest terms. So based on that, you can see the definition that was given, or I'm sorry, the formula that was given here. All these angles are inscribed angles. They're angles within a not a triangle, within a circle. And all these angles are angle ABC. They're called ABC for all those. To find the measurement of any of those angles ABC, you would take 1/2 the arc measure of AC. 1/2 the arc measure of AC. All right, so here is a circle down below where we've got an inscribed angle. We've got angle AOB, and we want to find so let me write in here really quick. We are actually in this circle below. I want you to find the measure of arc AB. So I want you to find the measure of arc AB. So that's what we're going to do with this circle here. Now going back to take a look at the circle and see what's given to us. So in this circle, we know that the measurement of angle, that inscribed angle AOB, we know the measurement of that inscribed angle is 20 degrees. And we want to find the measurement of the arc AB. So we want to find the measurement of the arc AB. And now we have enough information to find that measurement using the formula for inscribed angle theorem, the inscribed angle theorem. So since we know that the inscribed angle theorem says that the measurement, so I'm going to come around here on the other side, it tells us that the measurement, in this case our angle is AOB, the measurement of angle AOB is going to be 1/2 the arc AC, the arc that the intercepted arc AB. So let's fill in the information we know. We're given the measurement of AOB, that inscribed angle is 20 degrees. We know that. 1/2, and then do we know the measurement of AB, the arc AB? We don't, so I'm going to put X there. That's what we're trying to find. So I'm just going to use X to represent the measurement of that arc AB. So let's solve for X. So right now we've got 1/2 times X, so to get X all alone, we need to multiply both sides by 2. Whatever we do to one side, we have to do to the other side. So it would be 40 would equal X, or the measurement of arc AB would equal 40, which makes sense because we know that half of the intercepted arc is going to be the measurement of the central angle of your inscribed angle. So just to introduce the inscribed angle theorem and how we can use it to not only find the measurement of your of your inscribed arc, you can also, if you're given your inscribed arc angle measurement, you can find the measurement of the intercepted arc. And you'll get to practice that this week. So moving on, I'm going to move on. If you need more time, go ahead and click pause. Inscribed angle. So let's keep going with that idea and that theorem. And I want you to see if you can find the measurement of angle C. So the measurement of angle C, which is, I'm going to highlight that for you guys right there. There's our angle C. And I want you to see if you can use the given information on this circle. We've got some arc lengths and some other inscribed angle measurements. And see if you can figure out the measurement of angle C using the inscribed angle theorem. So go ahead and take some time and try to do this. Go ahead and click pause and try this in your math notebook. And when you're ready to check your work with mine, go ahead and click play. All right, I'm going to just remind everybody of that inscribed arc angle theorem that we just learned about on the previous slide. So that is the measurement of angle C, which we're trying to find, is going to be equal to 1/2 the measurement of that intercepted arc, which is going to be that arc AD. So this arc right here, AD, is intercepted by angle C, angle ACD, if you want 3 letters for that angle. And we know that the measurement of arc AD is 94, so we're simply going to take half of 94 to find our answer. So 94 divided by 2, and you get 47. So if you chose 47 degrees, if you chose A as your answer, you were correct. All right, I'm going to move on to the next slide. So we've now got a chance to use the inscribed angle theorem to find an angle measurement as well as finding an intercepted arc measure as well. All right, so what about if we have a tangent and a secant, or different types of, let's see here, let's talk just about different types of angles that can occur on or within a circle. So if we talk about, first let's talk about, focus on a tangent and a secant, or you can think of it as a chord. You can think of a secant as a chord. So here's our secant from A to C. That would be our secant. And then our tangent, remember a tangent is when a line or segment just touches a circle at one place. So our tangent, let's go ahead and use a different color here to show that. The tangent is going to be this segment from Z to C, right there. So we've got a tangent and a chord, and the vertex intersects on the circle at the point of tangency. So when we have this case where we've got an angle that is a secant and a tangent, and the vertex is located on the intersection of the circle, then the measure of the angle formed is half of the intercepted arc. So here you've got the angle measurement is going to be 1/2 the measurement of the intercepted arc. So that same idea here. So let's try this. Let's try. So what would be the value of x? What would be the value of x? So here we've got our chord. A to B is a chord. And then B to C is our tangent line. So we've got a tangent secant. We've got a tangent and a secant. So what would be the value of x? Again, we're going to take 1/2 the measurement of the intercepted arc. So 1/2, we've got 120. So that's going to give our measurement of angle x there. So 1/2 of 120 is 60 degrees. So it'd be 60 degrees. I'm going to go on to the next slide. If you need more time, go ahead and click pause. What about if you've got 2 secants that are drawn into a circle and they intersect inside of a circle? So we had it before in the previous example, our different segments were intersecting right on the outside of a circle. Up until now, we've been looking at cases like that, where now, what about if you've got your segments intersecting inside of a circle? All right, so if you've got 2 secants or 2 chords that intersect in the inside of a circle, on the interior, then the measure of each angle formed is half the sum of the measures of the intercepted arcs. Okay, so let's say we're trying to find the measurement of angle 1 in this diagram down here, the measurement of angle 1. So what we would do is we need to add our intercepted arcs, so the measurement of DC, that's one of our intercepted arcs, and the measurement of AB is our other arc. We need to add those up and divide it by 2. Divide that by 2. So I'm going to highlight the intercepted arcs here. So if we're finding angle 1, we would have to add this arc A or CD plus arc AB. And then same if we were trying to find the measurement of angle 2 in this diagram, this angle, we would have to add the arc AD plus the arc BC, and those measurements, and then divide those by 2. So ready to see an example? Okay, so let's just do one of these. Let's find the measurement of angle BXD. Let's do the top one. BXD. So if we want to find the measure of BXD, we need to look at the intercepted arc. So that would be arc BD, because we're trying to find the measurement of X, BXD. And then we're going to add to it the measurement of arc AC, and then divide that by 2. So let's go ahead and do that. So we're going to take half of the measurement of arc BD plus the measurement of arc AC. And then we would divide that total by 2, or multiply it by 1/2, however you like to look at that and think of that. The measurement of BD is 70 degrees, and the measurement of AC is 170 degrees. So we're going to take 170 plus 70, it's 240, divide that by 2, and you get 120 degrees. It's going to be the measurement of angle BXD. Now, looking at question number 2, if we needed to find the measurement of, do a different color here, the measurement of angle BEC, so this measurement here, we would have to use these other arcs. Now, if you're not given those arc measurements, use what you have to help you figure out what those measurements would be. So in this case, I'm going to go ahead now and erase everything I highlighted there. We know now the measure of BXD. We know that angle measurement is 120 degrees, right? And if we want to find this angle, BEC, we've got a straight line from C to D. We have a straight line. And how many angle measurements are in a straight line? 180 degrees. So since we already solved for BED, we're going to use that angle measurement to help us find the measurement of BEC, and the idea that those angles, both the vertex, create a straight line, and the straight line has a total of 180 degrees. So the angle measurement of BEC plus 120 is going to equal 180 degrees. So if we just take 180 degrees, subtract out that 120, that leaves the measurement of angle BEC to be 60 degrees. We're going to stop now because I don't want this recording to get too long. So we have covered all the ideas from Unit 8, Session 4. And we've gotten about halfway through Unit 8, Session 5 and what you're going to see in Unit 8, Session 5. You'll continue on to learn what you do when you've got an angle measurement of when the vertex is on the outside of a circle. So if you've got two tangent lines and they intersect outside of a circle, we're going to have a very similar pattern to if they intersect inside the circle, but now you're going to subtract the arc measures. All right, and that's it. So let's get to the key phrase assignment. Let me write that in. Okay, so the week of April 19th key phrase assignment, the question you need to answer is if you have a tangent line, a tangent line, and a secant or chord intersecting to form an angle, so when it intersects to form an angle, where will the vertex of that angle lie? Will it be inside the circle, outside the circle, or on the circle? So you're going to choose one of those answers and include that in your response for the key phrase assignment. And that is it. Remember to let me know if you have any questions as you're working on this week's assignments, and have a wonderful week.